All right, here's a homework question on tables. Increase here. So you can see this is question number 4 from 22. I am going to help you through solving it. So I hope you looked at it first. So we have a table of values here. Understand what first you're looking at. So we have days and we have a rate. And it's important to know if you're looking at a rate or if you're just looking at a function. And it describes an ice sculpture that's melting. That's the radius as it melting every day. And it said the first question is to approximate the second derivative at 8.5. So one of the things you're going to be asked is, can you do a derivative and can you integrate off a table? So how do you do derivative off the table? And the answer is we need to do the slope formula. So for A, if I want to know the second derivative at 8.5, I need to see if I can right here. So 8.5 is in between what two numbers here? It's in between 7 and 10. So to find the derivative, that means slope. And the formula to find slope with 2 points is y2 minus y1 and x2 minus x1. So the y values are going to be your r prime at t. So we're going to go 3.8 subtract 4.4. So it's negative 3.8 subtract negative 4.4. And then in the denominator will be your x values or t values, which is 10 take away 7. You do not need to simplify it. And what unit would you have if the table is a rate centimeters per day and you take the derivative of a derivative? That would be centimeters per day per day. This is what it would look like. Oops. How do I get out? Oh, done. Okay, so this is what it would look like for A. So it's y2 minus y1, x2 minus x1, and then the unit. All right, for B, that's it. There's not more to do. For B, is there a time between 0 and 3 for which the derivative is equal to negative 6? And this question is asking, understanding the mean value theorem, AROC equaling IROC. So is there a time there where the average rate of change is equal to the thing? Actually, no, I take that back. Is there a time from 0 to 3 where just this value is negative 6? And so at 0, you can see it's negative 6.1. At 3 is negative 5, and I want you to notice that negative 6 is in between that. So we have a theorem for that. So it is not AROC equals IROC. Instead, it's called the intermediate value theorem. So if it's continuous and it falls in between, then a continuous function, there must be a time between 0 and 3 where it has to equal negative 6 at least once. So how are we going to write that down? Let's do that right now. Go done. So first we have to write this down. Since, see, I can even do that, r at t is differentiable, and it said that in the question. R at t is also continuous. Can't be differentiable if it's not continuous. There must be at least one time where r at t equals 6, since 6 is in between, or is it negative 6, I mean, is in between negative 6.1 and negative 5. And that's the intermediate value theorem. So since negative 6 is in between that, and it's continuous because it's differentiable, there must be at least one time where it equals negative 6 because it's in between those two end values. All right, part C. Next one is, can you integrate with the table? So the second one was kind of a theorem, which is fine. The first one was derivative. How do we find derivative? Slope, right? y2 minus y1, x2 minus x1. How do we integrate off it? So to integrate off the table, they're either going to ask you to do a Riemann sum, rectangles, or a trapezoid sum. So in this case, they're asking you to do a Riemann sum. And it says use the intervals indicated. So there isn't one common width, so each one will be its own rectangle. So the first rectangle goes 0 to 3. So the width of it is 3. And then a right Riemann sum means we take the right value. So -5. And then I go plus. The next one, 3 to 7, is 4. And then a right Riemann sum we would use -4.4. The next one is 7 to 10, that's 3. And a right Riemann sum, that's -3.8. One more time, 10 to 12 is 2. And a right Riemann sum we would use -3.5. It does not say to use units, but you are integrating it. It would be in centimeters, because when you integrate a rate, it would just be that unit. Part D. In Part D, let me just show you my work. And we do not need to simplify that. In Part D, it says the height of the cone decreases at a rate of 2 centimeters per day. So I'm going to write that calculus. So the height of the cone, so dH by dt is -2 because it's decreasing. And then t equals 3 days. The radius is, so r is equal to 100. The height, h, is equal to 50. So I'm writing down these values. And what am I looking for? Find the rate the volume is changing. That's dV by dt. That's what I'm looking for when t equals 3. And it gives you a formula to start with. So we're going to start with the volume of a cone, and then we'll work at it together right now. So we took the information down that I was given in the question. We're going to start here. This is what I'm looking for, so I need to take the derivative. Sometimes I look, is there a way to substitute h for r or r for h so I have one variable? But there is no way in this question that's describing a relationship between the radius and height. I have to keep it this way, and I got to use the product rule. So I'm going to multiply in between this. So when I take the derivative of v, that's dv by dt, I'm going to do the first, and this is going to consider the first, and this is the second. So the first, 1/3 pi r squared times the derivative of the second. Now the derivative of h is 1, but it needs the hook dh by dt. Plus the second, which is h, times the derivative here. So 2 times 1/3, copy, and then subtract 1 to the exponent, and then times the hook for the radius, which is dr by dt. So there's the proper way of taking the radius. Now what is that when t equals 3? So what's the derivative when t equals 3? You don't need to simplify. We just plug those values in that you see above. So the radius is 100. The height is 50. Oh, sorry, the radius is 100. The rate for the height, dh by dt, is -2. Now the height is 50. We have 2/3 pi. The radius is 100. And the rate for the radius, we look at the table for the rate. So what's the rate when t equals 3, looking at the table? So this one we need the table. If I look at the table, it's -5 is the answer. And that's it. The unit here would be centimeters cubed per day. So volume, centimeters cubed, and the rate day is there, and we don't need to simplify that answer, and you finished it. All right, Mr. G Math, over and out. I'm proud of you for doing it. Do we have time for more? Maybe. I'll do one more. Next video will be the next question. All right, till next time.